Hi everybody, it's a pleasure to be here. So today I'm going to present on something different. The spinning jenny is it's a first application of Nextflow outside the field of bioinformatics. So this is a collaboration between me and Luca Cozzato, which is a bioinformatic, and I am a Ph.D. in quantitative economics. And I am working on agent-based, which have kind of the same issues that most of you have. So we started collaborating together, and what can go wrong? So the kind of models that I do have, again, the same issues of reproducibility and scalability. These are hard words, and that's fine, it's fine. I'm good like this. And so we just thought, why not try the same solution that you found for your own problem? So we implemented a pipeline for simulating the model I'm working on my thesis and solving some of the computational power issues and time issues, etc. So just the first quick introduction, what are agent-based models? Well, they're a system of stochastic discrete equation. They have no analytical solution. What does it mean? You have to simulate them. They are widespread all over different disciplines. In economics, they're kind of new. Technically, this is an economic history model, so probably first time this is done for economic history. But they can really be used for anything, population, evolution, meteor prediction, etc. What characterizes them is like that complexity arises from simple behaviors. You assign agents simple behavior, and a complex system emerges out of that interaction. To do that, I use NetLogo. NetLogo is a specialized program to do this. It's quite handy because it's easy to get. It's high language programming, so you basically code in English, very handy if you just want to pick it up and start coding. Kind of hard to do advanced stuff with, but it's widespread. Very hard to run in parallel, and I found myself with the issue of having to do, Monte Carlo of 1,000 for each parameter, and yeah. So you can see here, this should start, the video is started. So this is an example of NetLogo working for a simple epidemics agent-based, one of the examples you find in the program. As you can see, you have some initial parameters, you have a geographical space, and you get the interaction, and you get data out of it. So you get an output of data of your simulation. So what we did, we simply bounded all of this together through Nextflow. So we bounded NetLogo and R. They pass into Docker images, and design a pipeline for solving computability and portability problem. The code will be released soon on GitHub. Italian universities are very particular about what you can publish before you finish your PhD, so this is why there is a delay. It's annoying. It's very annoying. So what is my model about? Well, my model is about the first industrial revolution, which is one could argue, one of the most important events of human history. It was this fundamental shift that happened in Britain in the late 18th century, which started like a sustained economic growth that was higher than population for the first time. It was a fundamental shift. There are different theories about this. The problem is there is not that much data to go on, so I wanted to produce, how can we say? I wanted to try and reproduce one of the different explanations for this and focusing on one particular mechanism. So the fact that high wages were the reason for why England was able to industrialize at the period. So the model is somewhat complex. It kind of can be similar to the same city if you look at it. So you have households, you have farms and industries. The farms and industry hire workers and pay profits to other households, and then you get a macroeconomy out of it. It runs for 300 iterations. We explore 7 different parameters of it, and with 1,000 repetitions for each parameter. And this is what I get out of it. So as you can see, there are the different evolution of different economic indicators. There is GDP, the different sectorial contribution, prices, average wealth for household, and the line is when I introduce the industrial technology, and you see the behavior of the model changes. So what we do is we get the output from each of these simple, one run, and we bunch it together, and then through parallel netlog executions, and then we take the output, we concatenate, and we run some simple output analysis on it, some graphs, some regression, etc., which makes changes in initial parameters very clear, very fast, and which is very useful. So what happened is at the end, I get a clear idea of the different effects of initial parameter states without any effort, thanks to this pipeline. So which is, again, very good and very time-saving. Yeah, and that's it. So as you can see, for me, this has been pretty handy. And now we can go to question, and Luca can answer the technical ones.
I don't have any questions there. Is that correct? Yeah, okay. So I'll ask you, how did you find the experience with Nextflow? Or did you do much of that piece yourself, or was Luca doing the Nextflow integration?
He's doing mostly of the Nextflow. I'm more on the NetLogo side, of course. It wasn't the easiest, but once it's done, it's incredibly handy. Just if I have something, I have to implement something. It's not that much of work, and just being able to get a clear answer out of the complexity of it is just great.
And I guess, like, speaking with your colleagues in the area, are they using things like containers at all, or is this all completely new to everyone?
I think most of them aren't. It's mostly like, the university maybe has a system to parallelize this kind of stuff. But I'm quite sure they still do it by hand. Like, they get the output and then they analyze it, which is horrible. And I'm trying to get them into this, but we'll see. There's not that many people that do this, though. So.
Yeah. And I guess the choice of Nextflow over other languages, I guess that was partially, all Luca's fault there.
Yeah.
Great. Awesome. Well, thanks so much.
Thank you.